Hello, everyone. Today is day 26 of Coding Every Day. Today is February 10th, 2025 at 12:18 p.m. And today is a Monday. So, yesterday I did this problem, palindrome partitioning. Felt pretty good. So I'm in this map here. I'm done with the backtracking medium problems. I failed task scheduler. And I was going to take a look at, I think, design Twitter today, this problem. Then after, I'm probably going to do dynamic programming and graphs. So yeah, let's take a look at this one. I've read it a little bit, but not that much in depth. So our task is to implement a simplified version of Twitter, which allows users to post tweets, follow, unfollow each other, and view the 10 most recent tweets within their news feed. Users and tweets are uniquely identified by their IDs, integers. Say tweet ID, followee ID, follower. Okay, so followee is the one who's being followed, and follower is the one who followed the followee. Simply put, all right, so Twitter post tweet publishes a new tweet with the ID, tweet ID, and user ID, unique, fetches at most the 10 most recent, okay, so it could be less than that, IDs in the user's news feed. Each item must be posted by users who the user is following or by the user themselves. Okay, tweet IDs should be ordered from most recent to least recent. Okay, so I'm wondering why we can't just use a queue for that. The user with ID follower ID follows the user followee ID. Okay. Right. Alright. So our input is commands. So for post tweet, we'll get the user and then the tweet ID. Get newsfeed. So it's only themselves because they don't follow anyone. Okay. So I'm thinking we could have something called So the problem is we want to figure out how to structure our data. So I'm thinking we could use a map where we map a user ID, so let's say user 1, to everybody that they should, like everybody they follow and themselves. So these are all the people they should receive tweets from. So if you want to, so this is everybody that follows, that they follow. Can they unfollow? Yeah, they can unfollow. All right, and then, so does every person need the 10 most recent for them, or can we just, so what we could do is for every person, like every ID, have like the most recent tweets. But if they unfollow somebody and they get their news feed, it shouldn't pop up. So I think maybe what we should do is just have a like most recent feed. And then what's the time and space? So I was thinking what we could do is just have like everybody shares the most recent feeds, which would be, I guess, like the user ID that posted it. And yeah, so we could have something called like tweets, and it's just a list of tuples. So it's like the user that posted it and the tweet ID number. So something like this, to say like tweet 4, 1, tweet 1. So something like this. And then if you want to get the, well, actually this could be a set here. Like this. So what you could do is go through, so you have a counter to 0, and then you scan every tweet. So look at this one. If user 1 is in user 1's network, then counter goes up by 1, and then this is like one of the tweets, and you just keep doing that until the counter is 10 or until you're out of tweets. So with that would be linear time. And follow and unfollow would, so post tweet would just be adding a tuple to the tweets list. Get newsfeed would be the O of N process I just described. Follow would be adding to the network dictionary. We could call this dictionary network, I guess. And then unfollow would be removing from network. So this would work, but it's O of N. N log N for each. This is a very complicated space. Okay, so the struggle is, well, wait, N log N? Am I missing something? Because mine's N, right? And then, well, tweets would just be a Q. And we would just always add. Oh, wait, well, what's N? Number of followee IDs. Okay, so this is really like O of the number of tweets. Which is, could be bigger than, yeah, so there could be more tweets. Okay, so I'm gonna start, I think, by just coding it like this, and then go from there. Okay. Okay, so what do we need? We need self.network. So yeah, I'm gonna code this, and then I think after I do that, I'll be able to kind of maybe get some more insight and think about where I can go from there to try to make this function scale relative to N instead of the number of tweets. Okay, and it says M is the maximum number of followees. I didn't know that was a... I guess it's 100 in this case, like the number of people. Okay, and then self dot say tweets is a list. I think conceptually it makes more sense for me to view it as a queue. Okay, so anytime somebody posts a tweet, we will say self dot tweets dot append left tweet. We'll say tweet equals user ID tweet ID. Okay, so this basically just adds it to the tweets queue. Okay, follow. So if you follow somebody, that means you want to add them to your network here. So we'll say if follower ID not in network. So if they're not in the network, then we'll say, and it would be self.network. Self.network of follower ID equals a list with just follower ID, because you want to receive tweets from yourself. And if they're already in there, then we'll say self.network follower ID dot append. Oh, and it should be a set. Dot add follow we ID, like that. So we add themselves, so it would be like 1 1, and then if they follow 2, it'll be 1 1 2 in the set. Okay, and unfollow. Do I have to check if they're already following them? I guess I could. So we'll say if for now, I'm just gonna not do that, and then if I run into problems later, then I can just add it. So self.network of follower ID dot remove followee ID. Okay, so I think that works. All right, get newsfeed. So say count equals 0 while count is less than 10. We could say feed is empty list. Okay, so well, yeah, we also need I to be equal to 0. While I is less than length of so there's 2 stop conditions. We reach the end of the queue, or we've found 10 that apply to us. So we will say user, or like author, the author of the tweet, and tweet ID equals self.tweets of I. So it'll get the tweet at index I and then give us the author of the tweet and the tweet ID. So, and then if author is in, I don't think is a keyword there. Okay, so if author in self.network of the user ID, then feed dot append self dot tweets of I. Well, it's a list of integers, right? So we just want to return the tweet ID and count plus equals 1 and I plus equals 1. And then we would like to return feed. Okay, let's see if I get any errors here. Key error. If author in self.network is this the example case? I see. So user is not added because I only add them when they follow, but I should also add them if they post a tweet. Or I could just wondering if I could make this a default dictionary of a set. I don't know how to make a default dictionary where the value just equals whatever the key is in a set. I guess for now I could just say this part. Well, in post tweet we don't need to know the dictionary, but here we do. So I can just put this here. Does this have to be self? I know it's still here, but I want to see if that's... Oh, I see. It should be user ID here. Okay, so it works for the first test case. Let's see. Post tweet, so 1. Okay, so user 1 posts 100. So say 1 tweet 100. So 1 gets added. Follow. You can follow yourself. So I'm guessing you can't unfollow yourself. Does it say that anyway? I mean, I guess I could say if follower ID does not equal so that way you won't be able to unfollow yourself. Whoops, I forgot to add it as a test case. Okay, that one worked. Let's see here. So the tweets are 723, 724, 725, 728. Sorry, 726. 727. All right. Follow. So user 8. And then when we post a tweet, do I add them to the network or no? No. So 7's not in the network. So the first person that gets added to the network is 8. And they follow 8 and 7 like this. Eight follows 7. So it's not going to add another 7 because sets have to be unique. So then we unfollow. 8 unfollows 7. Get newsfeed of 8. So that should be empty. Okay, so here we're unfollowing somebody that we don't follow. Okay. And follow ID in self dot. So this just checks that they are actually following them. Oops. Okay. Okay, so we could do it this way. Let me just add some comments here. So if what if follower ID is not like if you, for instance, try to unfollow somebody but the user isn't in my system yet, then that would give me an error as well. So if it's not in the network, if follower ID is not in self.network, return. And I'm going to copy this. So if it's either one of those, then I should return. And if we make it here, then we're good. So if follower ID is not in the network, and they're equal to each other, or and I have to do this one first because it prevents this key error from happening. Wrong answer. Was it this part? It's interesting. This works though. I thought I just reversed the logic. If this one and this one is true, then you remove. So I just negated it. So I said if this or that. Oh, because I didn't negate. I see. I think I'm going the wrong way. So I didn't negate this. So if they're equal, then you want to return. And this one's right. If it's not in the network, then you want to return. And then if it's here, if it's not in, so if the follower is not in the network, okay, there we go. Forgot to reverse the logic within the conditions themselves. So I don't know if it's better to I don't know what's more readable. It's probably like this is more readable. If you just make each condition its own line. All right. So notably, I didn't use a min heap anywhere. And the recommended time complexity is n log n. So I think that means we pop n times. From a heap. So let's think about how we can rework this with a heap structure. So right now what I'm doing is storing everybody's tweets like this. Okay. So let's start with, if you have a user, you could store a heap of all. It's just hard because if you follow or unfollow somebody, you have to revisit everything. But following and so all of these are O of 1. So I'm thinking there might be able to, and this just seems like the most obvious sort of way to do it. And this is an O of 1. So I think these just manipulate the data structure, and then get newsfeed uses these data structures. Because adding to a heap is not constant. So I can't really, my hands are kind of tied with these because it has to be constant. So it's n time, let's look at the space, maybe I can give us a hint. So it's n times m plus n times m. Okay, so there's two m's. N is followee IDs. Okay, let's look at what big N is. Total number of user IDs. And M is the maximum number of tweets by any user. So this is one data structure. This is another, and this is another probably. Right now, mine is, I just have network and tweets. So tweets is equal to all of the tweets by every user. Okay, so I think N, so it looks like this part is you store every tweet like per person. So the number of people times all of their tweets. So my solution gets the most recent tweets, but we need to have it so, because of the way that we just always insert to the left and then check from the left. But we need to somehow make it specific to each user. So you could have a user and then like all of the tweets that are relevant to themselves or their followers. If we had that, then it would be really easy. But the problem with this is, so like if these are our users, their tweets. So if we had this data structure, then it would just be a matter of going through this list and returning every single one because they're all viable. And how to get the most recent one? Maybe that's a trick. Well, this could be a heap with all of the tweets that are viable. But then if you unfollow somebody, you're going to have to remove from the heap every single one of those tweets. And if you follow someone, you're going to have to add all of their tweets to a heap, which also seems like a lot of time. Well, N is the number of follow IDs. Because this is N log N. So log N is like adding or removing from a heap, if I remember correctly. And N is the number of people they are following. So it's the number of people they are following times popping from the heap. Okay, what if you map each user, instead of to the viable tweets that they care about, if you map each user to the tweets that they have posted? Like this. So if each user is mapped to their own tweets, and let's say user 5 follows 6 and 8, we know, and themselves, like they have to get their own tweets. So if user 5, and these numbers aren't possible, but so if user 5, and let me just get this. Okay. So if user 5 were to get their news feed, and they follow 6 and 8, you'd get all of these tweets. But you'd have to get them in a heap based on time. So what you could do is for every tweet, store its like timestamp. And then you basically add all of these tweets together, which I don't know the time complexity of like concatenating two sets. So you could add all of them together into one giant tweet list. And then you could heapify this. You could heapify this and then pop and then get the like K largest. Yeah, K largest. If we're doing it by timestamp. The problem with this is you would basically have to add all of these sets together. This data structure would be very easy to preserve though. It doesn't really change with following and unfollowing. And you can never remove a tweet. You can never remove a tweet. So all we would have to do, I think this would still be n though. Well, it's not n. Let's think in terms of the. So the time complexity to add all of these together would be basically the number of users, which they define as n. Is that it? Because you do one operation for every user. Well, if we say for every user, you have to concatenate a set or take the union of a set. I'm going to look that up. Time complexity to take a union of a set. Okay. So it looks like taking the union of a set is linear. Yeah, that makes sense. Because if you extend a list, it's linear. So you'd basically have to, for every user, if only there was a way to have a giant list of tweets, but just filter out all of the irrelevant ones. That's kind of what I was doing before. All right, I'm at 40 minutes. Okay, so these are the two ideas that I had. So you could map every user to their tweets, and I think that was supported a little bit by something I read over here. N times N, total number of user IDs, and M, maximum number of tweets by any user. And then this is total number of user IDs and maximum number of followees. So does that mean we also want users and who they're following? Yeah, I have that already, right? That's network. So users and who they're following, and then users and their tweets plus N. So I think this could be relevant. I just don't know how to take this and get the most relevant tweets in linear time. I have an idea. Maybe we could associate each user with its most recent tweet. So like the timestamp of their most recent tweet. So let's say this was at timestamp 6, this was at timestamp 7, and this user was at timestamp 5. Okay, so if you're 5, you take a heap of this. So you heapify it, which is equal to the number of users that you follow, which is lowercase n. Yep. And then you would take the k largest, which is log n. Well, no, not necessarily. You'd have to do it manually, because for instance, let me change up the numbers. Okay, I like this where this is going though. So if you have, let's say these users, like that, and this is like the timestamp of their tweet, so 10 would be the most recent. So you can't just go, okay, 10 and then 6 and then 3, because this is only their most recent tweet. They have many other tweets. So they could have their second most tweet at 9. So what you'd have to do is pop 10 to your answer, and then repopulate this with the next most recent. Which, let's say it's 9. Then you would add this to the heap. So this part is the heap, because you always have to get the minimum of the minimums. And then 9. And then let's say the next tweet they did was at timestamp 5. So you add that to the heap. Okay, so how can we... Is this also heap in this dimension? Is tweet ID, like, does it have to be linear? I don't think so, right? Like, it doesn't have to be consecutive 1, 2, 3. Well, we could have like self.tweet time. When you post tweet, self.tweet time goes up by 1, like that. Okay, so this part, is this part also here? This part might be able to just be a queue. and then we just always add it to the left. And we pop left. We could just use a list and pop right, append right. All right. Okay. I think this would work. Because this is a heap. And this would just be a queue. So the heap is out of the most recent tweet of all the users. Okay, so the connection thing is fine. Well, we would have to make a heap. All right. I don't think we need that anymore. Okay, so user to tweets. So when you post a tweet, and this will be a dictionary of integer to list, user ID to list of tweets. Okay, so I think what we want to do, let's just make it here. Whoops, here. Okay, so we'll say no, we want it to be a list actually. Okay, so we'll say user to tweets of user ID dot append tweet ID. Do we need the tweet time? Yes. Do we? Yeah, because we need to determine these. These will always be in order, but this will not be. So we need to use tweet time. So we'll do the tweet time and the tweet ID. All right, let me just make sure that's working. Follow and unfile should be fine. And I'll just print like that. Okay, so at timestamp 0, it posts tweet 10. At timestamp, what's this? A user to posted this tweet, and this tweet is at timestamp 1, tweet ID 20. Okay, so that's good. So what we want to do is also have, and I'll just make this go down by 1 every time, so we can do a min heap instead. Is it like that? Is it from collections? No, I think it's just import heap queue. All right, so we'll say self.minheap equals heap queue. Okay. So we want to have only the most recent ones in there. Okay, so this is, we need a little bit more granularity than that. So if user ID is already in self.user to tweet, so if they've tweeted before, we want to remove previous tweet from heap and add new tweet to heap because it's the most recent and we only want the most recent for that user. And if they're not in it, then just add new tweet to heap. So I think we could just have it like that. Okay. So if they're in there, then that means we've already added, they already have something in there. So that means we can remove it from the heap. So we'll say heap q dot heap pop. In heap, we want to pop the recent, we want to pop their last tweet. So it'd be self user to tweets of user ID of -1. So most recent tweet is this. And then we want to add, so heap q dot heap push. Is it like that? In heap. Now we want to add this tweet, which is so we're going to do tweet time, self.tweet time, and tweet ID. We want to add this tweet. Self.minheap. Let's see what this looks like. Just empty. Oh. So we're not adding it to the, yeah, so we could do that here, I think. Push new. So push user's new most recent tweet into heap, and then add wait. This part's supposed to be O1. So I think what we can do is actually just not worry about the heap stuff here. So we'll have, yeah, I don't really have to do it. Okay. This is good. So we'll have each, all their tweets in a list like this, like tweet 1, tweet 2, tweet 3, and user 9, let's say they do tweet 4, tweet 5, and tweet 6. So when it's time to get the feed, we will look at every user that they follow and get just the last element. So we don't really need to keep a running heap because so we can just get the last element, which is O of 1. And then so we can get the last element, put all of them into a heap. So put those into a heap, which is O of n. And then pop from heap, pop from dictionary, and then push to heap from dictionary. So we'll heapify this. We'll pop the most recent one. And then what we have to do is remove from here whichever one we popped. And then add this one to the heap because now this is the most recent tweet. Because it could be that these two are more recent than this one, in which case we would want to add these two first. So I'm thinking this object might need to indicate which user it's from. So within the tweet, and so we need the timestamp to identify these. I think we also should include the user ID so we can reference which dictionary needs to, or which list in the dictionary needs to get popped. Okay, so it's going to be tweet time, user ID, and tweet ID. So this is our tweet right here. This is tweet. So we don't actually have to do this. All we need to do here is just map the people to their tweets. So we don't need to do this either. So all we have to do is map the people to their tweets. So we can just say self.user to tweets dot append tweet. Wait, no. Of user ID dot append tweet, like this. And since it's a default dictionary, it will work. Okay, so if I run this, okay, it seems to be working. And then it's going negative. So the most recent one will be the most negative one, which is good. Okay. So that's what we want here. Okay, so for get newsfeed, first we want to get, so we want to heapify most recent tweet from all, from everyone we follow. Okay. So we'll say min heap. All right, so first of all, we have to get every one of our followers. So, and we have network. So for followee in self.network of user ID. So for each followee in my network, I would like to grab that person's tweets. So self dot user to tweet of followee. So that grabs all of their tweets, and we want to get just the last, most recent elements. Should we pop it? Can we pop it here? No. I don't think so, because if we pop all of them, I don't think we should pop. So we'll just grab the last element. So that's their so followee most recent tweet. And then we want to append that, or I guess we could just push it to the heap actually. So heap q dot heap push self dot min heap, and then their most recent tweet. And we probably want to reset it every time we get the newsfeed. Self dot min heap. So generate heap from most recent tweets from everyone we follow. Okay, so I want to print min heap here and see what this looks like. Yeah, so this part. So are we getting newsfeed of somebody who doesn't exist yet? 1. So network, they posted a tweet that doesn't put them in the network. If they post a tweet, that should put them in the network, right? Well, we could definitely put them in the network when we get there. When we post a tweet, we don't need that, so we could just check it here. So if user ID not in self.network, then we'll add them to the network. So we'll say self.network of user ID equals, and it's a set, right? Oh, right here. Yeah, right here. Okay. User to tweet. It doesn't. User to tweets. Okay, I was a little confused by the debug output. So the most recent tweet of, so what's, oh, I'm printing it twice. So this is our dictionary. So the most recent one is this tweet. The most of followee 2 is this tweet. And then let me just print. Well, okay, so this generates a min heap. And then we want to say feed is empty list. I could do that down here. So feed is empty list. And we can say or if they run out of. All right, so at every step what we want to do, we can worry about the stop condition later. So what we want to do is pop from the heap. Okay, so now we're at this stage. So pop from the heap. So heap q dot heap pop from min heap, self dot min heap. I don't think it has to be self. I don't think we have to define it up there. We can just do it right here. Okay, so we want to pop from the min heap, and that will be a tweet. Most recent tweet of any follower. And then we will get the time, and what is it? Time user. Okay, so pop from heap, then we'll pop from dictionary. So add that user. What we want to do is pop self dots, what is it? User to tweets, right? Okay, so of user, so whoever did this tweet, we should pop from there. And this is also going to mess up the dictionary. So we should like copy the dictionary beforehand, maybe. Self dot tweets. I don't know if this will actually work because it's not really like a deep copy, I don't think, because it's each key just points to the reference of the list. So it's still going to point to. Let's just see if it works for one person first. All right. So we pop from the dictionary. And now, well, do we have to? Yeah, we have to. I was thinking what we could do is just, without popping this one, we could say, like we can just push this one, but then we need some sort of index for every single one. So heap q dot heap push min heap, and then we want to get basically this again. I'll say next newest into heap. And then do this again. If it's not empty. I think we could say while length of feed is less than 10 and min heap has anything in it. How's that out of range? Oh, this part's out of range. So if they follow somebody but they don't have any tweets. Yeah. So let's just say so feed is a list of integers, right? All right, so we can append tweet ID. This is just setting up for next time, right? So we can put that there. So this should just return feed. Yeah, okay. So it's working, but then we have to I don't know if this is gonna work. What did I call it? Ticked copy? I have a feeling that's not gonna work. Yeah, because it just points to empty list anyway. So I could make a deep copy. Is there any other way? I could also have a pointer. So I could have this and then a pointer. And so that's in or I could make a deep copy. The pointer probably makes more sense. So my idea would be it would just start at 1 and you would do like -1 and then you move it over to -2 and then -3. So that way it just points to whichever one instead of popping it. We could just push at that pointer. So let's try that. So this is user to tweets. So when I construct it, or what I could do is just for every person, I could generate a new dictionary called pointer, and for every followee, what could I call it? I'll just call it tweet pointer. So it'll be just a new dictionary. So for every followee, we want to say that tweet pointer of followee equals 1. And then should I put that after? So if they're if followee, if it's an empty list, then we don't really want the pointer, I guess. If they don't have any tweets, we don't really need the pointer. So let me print tweet pointer here. One. So instead of popping this, so like you just say like K equals tweet pointer followee. So it's like the kth most recent tweet. So we get the most recent tweet from all of our followers, or all of our followees, everybody we follow. We extract the information from the tweet. We add the tweet ID to the feed. And min heap for popping from, but then we're adding it, but only if we can. So eventually it would run out. Okay. So if they have any tweets, if the followee so why followee? So yeah, we want to pop, but shouldn't it be from user? Because this is the person that created the tweet. So don't we want it like that? So the author of the tweet, yeah, so the author of the tweet would be like 9 in this case. So if they have any tweets left, then K will be whatever the pointer is currently. And then we want to push this one. If they have anything. But we're no longer popping, so it should always be populated. So instead we want to check if K is out of bounds. So if K is greater than the length, if it's greater than the length of their tweets, then we should exit. So if it's less than or equal to, because if it's, let's say 3, 1, 2, 3, then we're good. But if it's greater than that, then we don't want to do this. So we set the pointer that we're at. If the pointer is greater, so if it's outside, then we stop. Otherwise, we want to push heap push. So push into the heap the tweet at pointer K, and then we want to increase for next time tweet pointer of author, right? Followee. Like that. So it looks like we're duplicating everything. Let me see if this does something. Okay. All right. Let me comment this up a bit. So I don't need any of that. All right, so I guess what I'd like to do here, so tweet pointer, don't think I need that. So let's print generated pointers. Okay. So let's print our feed and min heap. Okay. So one posted 2 tweets. Two followed one. Get newsfeed of 2. So it should be both of these. So what are we doing here? Heap queue. So yeah, add every person's most recent tweet to heap. So it's in the heap. It gets it from the heap. Let me print. Somebody post a tweet. Let me print current. Say all current tweets. User to tweets. What's wrong? Self. Okay. So user one has these two tweets. Okay. Min heap. So we added it to the feed. So why is it? Let me see what we're adding and removing from the heap. I think it has something to do with the k values, perhaps. I think we're at negative. Are we at -0 or something like that? Alright, so print added this to min heap. Oh, am I not? No, this is it. Print increased. All right, let's see what this does. Why does that not work? Okay, so we added 102. Oh, do I not have F? Okay, so we added this to the min heap, increased k to 2. So it should work. So k is 1. Now k is 2. Okay, let's see what this is. rinse all authors' tweets. I think it should be less than or equal to. So why is it duplicating it? This part's right. I think it's doing something at the beginning that's not right. So K is 1, so it's this. We add it. K is 2. Min heap. So the min heap is this. So we pop from the min heap. Oh. Yeah, I think it's because we're not accounting for this change. Like whatever one is set as the minimum here. Okay, so that's our min heap, so we pop it from the min heap and add to feed. So K is 1. So then we add this to min heap. Increase K to 2 for next time. So this is the min heap. So we pop it from the min heap. Looking at the wrong case. Okay, so this is the minimum. So we pop it. And now, OK is 1. So I think it might just be when we do this, we don't want I feel like we have to move K somewhere here once. All right. All right, let's see. So out of all the tweets, this one's our only min heap. Okay, so what's happening is we're adding it to the min heap. So K should really start at 2 because all of the other ones have already been added to the min heap. I think that's what's happening. So K should really start at 2 because all the other ones, yeah, okay. So the idea was right, but the problem was these were all already added to the min heap. So we really have to start here if we're going to get the next element. What was happening was we were adding this one twice. So that's why we were getting duplicates and stuff like that. Okay, so this solution seems really complicated, probably because of all these print statements I have. I don't even know if the runtime is better. I think it is, but let me clean it up a bit and try to analyze it. So let's get rid of all the print statements. And does it work if I go like this? Does that give me an error? Okay, that works. All right. Okay, so these are good. So add follower. Yeah. So add followee to set of follower. Is this one? Then cannot unfollow yourself. Must unfollow some. And then this one is just like you kind of have to exist in the system already. Okay. Actually, so it's a user and a list of all their tweets, most recent at right side. Network. It's actually user ID. And then this is timestamp of all tweets. So this one is user ID and then set of everyone. Default set of all user IDs. Okay, so that just leaves us with this part. Make sure I didn't mess anything up. All right, good. All right. So this part is O of 1. So first let me calculate the big O in notation and see if it's even faster than what I had before, or if it's similar or worse. So this is O of 1. O of 1. Okay, so for followee in self.network of user ID. So for this user, we're going through every buddy that they follow. So for a user, we're going through everybody that they follow, which I believe this calls little n, lowercase n. Yeah, okay, so lowercase n. And then we are pushing to a heap, which is login. Okay. And this part is at most 10. We are pushing from a heap. Okay. Awesome. So it's actually the desired time complexity. Great. Okay, so all of that time was worth it. All right, so how this works is we look through everybody that someone follows. And we add all of their most recent tweets to a heap. And then we pop the minimum of those most recent tweets and then add that author, add their next most recent tweet to the heap that we're popping from. And to determine that without messing up the dictionary, I use a pointer, which I call K, which is like their kth most recent tweet. So for instance, if you have a user 1 and user 2, and let's say user 1 posted a tweet at 5 seconds in and let's say 7 seconds in. And then this user 2 posted something at 4 seconds in and something at 8 seconds in. So first we generate the bin heap of all of the most recent. And then let's say that these are followed by some user X and we want to get X's feed. So we generate the heap and then we pop. So T8, in this case, T8 would be the most recent. So we add that to the feed. So feed. And now, because T8 came from user 2, we now add this to the heap. So now the heap looks like this. And now we see that T7 is the next one. So then, because that came from user 1, now this is the heap. So essentially you just kind of always are keeping track of the most recent from any follower and compile all of those into a heap. I don't know if there's an easier way to do it, but I just used, honestly, I think this is fine. I think it's pretty simple. It took me a while to get there, but I'm glad I was able to stick through it and actually solve it in the desired time complexity. Initially, I did this problem where to get the news feed was equal to just all of the tweets in the system, but now it is equal to just the the number of people that you follow times like the log of the number of people that you follow. So it's a lot faster. Yeah. So thank you everybody for watching. I believe that was day 25. So I'm really looking forward to tomorrow, because with that, I'm gonna call an end to the heap and priority queue for now. And tomorrow I'll either do a graph problem or a dynamic programming problem. I might try doing climbing stairs on my own, just to remind myself the basics of dynamic programming. I've done a bunch of graph problems, so I'm more interested in kind of diving into dynamic programming. But yeah, everyone, thank you very much for watching. It's a bit of a long video today, but I'm really happy we were able to stay focused and just make an awesome solution. So thank you for watching.